In today's video, we're looking at a large granular laterally spreading tumour sitting right at the ileocaecal valve, where the small intestine meets the large intestine. This is one of the most technically demanding locations in the colon to work in, and to remove the tumour, we're using a technique referred to as SITE-PCM, and this acronym should make sense to you by the end of the video. Before we get into any procedural footage, let's first remind ourselves about the layers of the bowel wall. And this illustration from the SEER training site out of the National Cancer Institute is a good reference for you to follow along with. So the innermost layer is the mucosa, and it's where the tumour lives. Right underneath, you have the submucosa, which is a thin layer packed with connective tissue and small blood vessels. And importantly, the tumour doesn't actually reach down this far. Below that is the muscularis propria, which is the muscular layer, and when you're dissecting, this layer is completely off limits. ESD, or endoscopic submucosal dissection, is essentially a procedure where you shave the mucosa off the submucosa without ever dropping down into that muscular layer. And to do that safely, you first inject fluid underneath the tumour to create a cushion, or a bit of separation between the layers. This separation is referred to as the plane, and you can see that annotated in the illustration. Traditionally, that cushion between the mucosa and submucosa was held open with gas, so the operator would pump air or CO2 into the colon, distending it much like inflating a balloon. And this technique is referred to as insufflation. A distended wall is easier to see into, and that's exactly why this has been the go-to approach for decades. But distension comes at a cost, because when you stretch the wall, sure, you're opening up the lumen, but you're also stretching the plane along with it, pulling it into a shape it wouldn't naturally be in. That matters most in tissue that's already fibrotic, meaning it's been stiffened by prior scarring, a biopsy, or an early attempt at removal. So the alternative is SITE, which stands for saline immersion therapeutic endoscopy. Instead of gas, the colon gets filled and continuously flushed with isotonic saline. And remember that this isn't just plain water, but rather sterile salt water matched to the body's own salt concentration. The issue with plain water is that it can make the tissue and the specimen more friable and fragile, requiring more energy from the knife to work efficiently during dissection. So saline immersion is ideal because it keeps the field clear through three mechanisms that work in tandem, those being visibility, buoyancy, and blood dispersal. Regarding visibility, using isotonic saline means there's no air-liquid interface, or just no boundary between two different substances. So small structures like vessels appear earlier than they would in an air-filled field. The second point about buoyancy is relevant because the tissue you're dissecting actually floats upwards in the saline, which does a lot of the work that external traction devices like clips or bands would otherwise have to do for you. Lastly, the point about blood dispersal is very relevant because if bleeding happens, the blood spreads out into a larger volume of fluid instead of pooling as a film right over the lens. Okay, now that we've hopefully understood SITE, we'll move on to PCM, which stands for Pocket Creation Method. This one has nothing to do with saline, instead it's about the order you cut in when excising the lesion. In standard ESD, you cut a full circle around the tumor's edge before you start dissecting underneath it. And you can see that on panel A of the illustration by Ide and colleagues published in Clinical Endoscopy in 2022. This conventional technique is fine for smaller lesions, but for a larger one, once that full circle is cut, you have a flap of mucosa that loses its tension and collapses back down, leaving you working in a flattened space that's much harder to see into. The pocket creation method is different in that you make one small opening at the edge of the tumor, tunnel straight into the submucosa, and hollow out a pocket underneath the lesion before you ever finish this rounding cut. In this case, the mucosa, still attached at the edges, acts like a built-in flap that holds that pocket open for you without needing any external traction, and this is illustrated nicely for you on panel B. So if you put those two ideas together, you have SITE-PCM, and in a nutshell, this is where you tunnel into a submucosal pocket, and you do so entirely under saline water instead of in an air-distended field. And this combination generally gets reserved for the cases where standard ESD tends to struggle. For example, if there's fibrotic tissue, vascular tissue, or any tissue that's been manipulated before, whether it be from biopsy or a procedure. So very soon we're going to look at some procedural footage from an interesting case where the lesion was located right at the ileocaecal valve, which is the junction where the small intestine empties into the large intestine. The anatomical location complicated this procedure, and to understand why, I want to briefly detail the anatomy of the ileocaecal valve. So the illustration you see in front of you is from Pollard and colleagues, and you can see how the valve itself is formed by two folds of tissue, a superior lip and an inferior lip. and where they meet, they form the ileocaecal junction orifice. On either side, those lips are anchored down by two ridges of tissue called frenula, a medial frenulum towards the middle, and a lateral frenulum towards the outside. Together, this whole structure constantly changes angle as the dissection proceeds, and this is substantially different from working on a flat stretch of colon wall. On top of that, the tissue where those two lips meet is typically more fibrotic than the surrounding area, which, as we just covered, is exactly the kind of tissue that makes the plane hard to hold on to. Another challenge in dissecting a lesion at the ileocaecal junction is its thickness. The cecum, the most proximal part of the colon, is the closest to the small intestine, and it also happens to have the thinnest, most compliant wall in the entire organ. Less tissue means a smaller safety margin and less room before you're at risk of perforation. And another thing to note is that gas insufflation actually makes this worse in this specific location, since distending a wall that's already thin is much harder to control. Now, for some added technical context, let's briefly discuss the equipment. The knife used in ESD doesn't cut mechanically, instead it uses an electrical current shaped by a generator. That generator can be set to different modes, each one shaping the current differently depending on whether you need to cut, coagulate, or both. One of those modes is called endocut, and it works by delivering the current in rapid pulses, alternating between a cutting burst and a coagulating burst. And that's what lets you cut and seal small vessels at the same time. In this case, a specific version of endocut called endocut 1 was used, and it's generally used for thinner, more delicate tissue like GI mucosa. It was dialed in at 141, and those three numbers each control something different. The first is the effect, which controls how much coagulation gets blended into each cut. A low number like 1 means a cleaner cut with less heat spreading into the surrounding tissue. The second is the cut duration, which controls how long each individual pulse lasts. And the third is the cut interval, which is the pause between pulses. There's also another mode worth knowing about, and it's called swift coagulation. In our procedural example, it's set at 2.5. But this one isn't for cutting, it's specifically for controlling bleeding by sealing a vessel before or after it's been divided. Swift coagulation produces a shallow effect than forced coagulation, meaning the heat doesn't travel as deep below the surface. That's a deliberate safety choice because you want just enough heat to seal a small submucosal vessel without enough depth to reach the muscular layer sitting right underneath it. Remember that we want to avoid the muscularis propria at all costs, especially somewhere like the cecum where the wall's already really thin. And one last thing before we get into the footage. The SITE and PCM techniques themselves are documented in the published literature by Despot and Mourinho, but the specific generator settings you're about to see are the operator's own reported approach for this particular case. It's not a standardized protocol pulled from a textbook, and different operators may reasonably tune these numbers differently depending on their own equipment and experience, and that's just worth keeping in mind as you watch. Now, moving on to the procedural footage, the first task is to properly assess the lesion. To do this, you'll notice the operator switching between two different imaging modalities. The first view is in TXI, which stands for Texture and Color Enhancement Imaging. It's designed to bring out surface detail and color contrast that's harder to see under standard white light. Now you'll see the mode switch to NBI, which stands for Narrow Band Imaging. NBI is used specifically to highlight the vascular and pit pattern on the lesion's surface. We'll refer to this step as optical characterization, and it's essentially just reading the lesion before deciding how to proceed, since the surface pattern can hint at whether a lesion is safely resectable endoscopically or whether it's showing signs of deeper invasion. Once that assessment is done, the operator moves into position with the knife itself to create the plane. Remember from earlier that the plane is a space created by the operator by injecting fluid beneath the tumour to separate the mucosa from the submucosa. Right here, that's exactly what's happening. As fluid goes in, you'll start to see the mucosa lift and dome to form that cushion we discussed a few minutes ago. And that blue you're seeing is a dye, typically indigo carmine, that's mixed directly into the injection fluid so the operator can actually see the cushion forming in real time. And so here's the mucosal entry point. Notice that the shape isn't a full circle, it's a singular opening, which is consistent with that pocket first approach from the PCM section. Standard ESD would cut the full circumference, but here there's only one entry point, and the rest of the dissection happens through it. The operator continues advancing through the submucosal pocket, and you can see the dye-stained tissue extending further across the field as the dissection progresses. Here, the knife is being used to seal small vessels before continuing, likely with swift coagulation, which, if you recall, is the shallow coagulation mode we covered earlier. Here, bleeding has occurred, and you can see how the saline handles it. Rather than pooling on the surface the way it would in an air-filled field, the blood disperses into the fluid. So the operator continues flushing the area, and the field clears without the view being fully lost. Now you can see a network of small vessels clearly visible within the submucosal tissue, branching across the field ahead of the dissection. So this is the visibility mechanism that we covered earlier. And without gas distension or an air-liquid interface, vessels like these are visible before the knife reaches them. The operator can see this branching pattern in advance and plan around it. Also, notice the fibrous strands crossing the submucosal space, clearly intact and distinct against the tissue around it. There's no collapsing or fraying or blurring into the surrounding structure. And so this is the plane staying legible as the operator works, holding its shape rather than degrading, which is one of the core advantages that saline immersion offers over standard air-based ESD. At this point, the specimen is attached by a single remaining strand of tissue. Everything else has already been separated along the plane. Once this last connection is divided, the lesion will come off free as one complete piece, or an en-bloc resection. That matters because it gives pathology an intact specimen to examine, with clear margins rather than fragments that are harder to assess for complete removal. Now that the specimen has been removed, the operator performs what's called post-resection hemostasis, which is going back over the entire resection bed to check for any vessels still exposed. With the resection and hemostasis complete, the operator now closes the defect, bringing the edges of the wound together. You'll notice that these clips remain in place as the procedure ends, and that's intentional. Endoscopic clips aren't retrieved, they're left to hold the tissue together as it heals. Over the following days to weeks, they loosen naturally and pass through the digestive tract on their own. After retrieval, the specimen is pinned out flat before being sent for pathology. This preserves the tissue's true shape and orientation, which is needed to accurately assess the resection margins and confirm the tumour is completely cleared. So now SITE-PCM should make a little more sense to you. SITE means dissecting in saline instead of air, so vessels are visible before they're cut, and blood disperses instead of pooling. PCM means a single entry point instead of a full circumferential cut, which keeps the pocket from collapsing as the dissection continues. SITE stands for saline immersion therapeutic endoscopy, while PCM stands for the pocket's creation method.